Welcome to a new Acrylic Wi-Fi Heatmaps tutorial. In this video, we're going to work with the Wi-Fi planning section. This is one of the 4 main sections of the software, and definitely a crucial stage when designing a Wi-Fi network from scratch. We're talking about the pre-deployment stage, where no access point or cabling has been placed yet. Before placing any access points, it is important to first analyze where they should be located to maximize our network performance. This can be achieved thanks to the planning section, where we got a prediction on how the signal will propagate through the different rooms. Let's dig into this now. We have selected the first section at the top of the window, and we've already loaded a blueprint. From this point, we're going to design our Wi-Fi network. First, let's take a look at the different stages that we should go through. If we click on the menu, we can see we have 3 different options: Wall Editor, Access Point Editor, and Heatmaps. Right now, the Wall Editor is selected as we can see in this blue circle. It's time to add all walls, doors, windows, and any other constructive element to the map. We will use the blueprint as a layout. First, we select the material from the many options available. We choose red brick and set the right thickness. In this case, we increase the thickness to 19 centimeters. Now we click on the blueprint and we start drawing the wall. We can check the wall length as we draw it. We keep clicking until we get to the initial point, or we click on the OK button in the right bottom panel. We do the same with the rest of the walls. Once we defined all walls, it's time to move forward to the next stage. We click on the menu and select Access Point Editor. From the right panel, we can add new access points. We can select whether we want the access point to work in 2.4 GHz, 5 GHz, or both. We then select the Wi-Fi standards, the antenna type, channel width, and channel. We can now click on Add AP. We can click several times to get copies of the same access point. In this case, we're going to create 5 access points. Each one of them has the text Dual on it. This means this access point is working in both frequency bands. Also, we can see 2 circles. The green circle represents the radiation pattern for the 2.4 GHz frequency band, whereas the blue circle represents the 5 GHz frequency band. We can rotate them independently to adjust it to our needs. Now, let's make a first approximation of our Wi-Fi network. We choose several locations, trying to cover as much area as possible. Now we can select the last stage from the menu, Heat Map. Oh, this doesn't look too bad. We are visualizing the expected signal strength. Most of the area is covered with good signal. Let's now select a different parameter. We select now Signal to Interference Ratio. Now we can see a completely different picture. There are a lot of red areas which indicate a high level of interferences. We need to fix this. Why is this happening? You can check one of our articles about channel interference. I'll leave a link in the description. We click on Channel Coverage. We can now see here where the problem lies. The only thing we can see is a big yellow area. That's not what we would expect for a channel coverage. We're using the same channel for all APs. That's why we had such a bad co-channel interference. Let's fix this. We edit our AP's configuration and assign channels 1, 6, and 11, avoiding 2 nearby access points to share the same channel. Now things look better. There aren't 2 same-colored areas touching each other. We can now revisit the Signal to Interference Ratio option and check how things have changed. This heat map has also improved dramatically. the high level of interference has been solved. As we have seen, it's important to check the different options available in this section. They will provide insights about the predicted performance and health of the network, which is critical at this stage. We're going to take a look at the two remaining options, number of APs and AP coverage. The first one represents the network redundancy. This may be an important factor depending on the project requirements. Some industries, such as healthcare or manufacturing, may require high redundancy standards. In this case, the warmer the color, the better the redundancy. Finally, if we select AP coverage, we will visualize the area that is being covered by each access point. This may be important to detect both APs covering too big areas or those covering too little. For the latter case, it could mean we have too many APs, so we could either remove some of them, thus reducing the budget, or relocate them, improving the network health in different areas. We hope you've enjoyed this video tutorial. Thank you so much for watching, and please stay tuned for new videos.